Here's number 14 from the Larsen worksheet. G of x equals 4x minus 7 all over 2x squared plus 3x minus 2. And like in number 13, we're going to use a partial fractions to break this up. So we can factor this to be 2x minus 1, x plus 2, 4x minus 7. And again, my center is going to be 0, so that's nice. So g of x equals this, and then again we break this up, a over 2x minus 1, b over x plus 2. And then you can see we just get a common denominator of 2x minus 1, x plus 2. And here we have our numerators are equal if the denominators are equal and the fractions are equal. And we pick convenient values, so if I put negative 2 in here, negative 2 plus 2 is going to zero out, so I just have b times, and if 2 times negative 2 is negative 4, and negative 1 is negative 5b. And if I put negative 2 here, I get 4 times negative 2 is negative 8, and negative 7 is negative 15. So that means that b is going to be 3. Now if I put 1/2 in, so the b will zero out, because 2 times 1/2 is 1, 1 minus 1 is 0. Then I have 1/2 plus 2a. Well, 2 is 2 halves, 4 halves, excuse me, plus 1/2 is 5 halves. So 5 halves a equals, and then if I put 1/2 in here, 4 times 1/2 is 2, minus 7 is negative 5. And if I multiply by 2 and divide by 5, I end up with negative 2. So there's my a and my b. And because this had a negative sign, I put the a over here, negative 2, 2x minus 1, and I put the positive, leading sign positive in front. B, which is 3, all over x plus 2. All right? So I just reversed these because the a had a negative and the b had a positive, so we usually like to have the positive sign leading. And then we try to get this in our geometric series form. Move this up a little bit. This is kind of a long problem. There we go. I think I got it all in there. So we just use the commutative property to reverse these. And we need to have a 1 here, so I'll divide everything by 2. So 3 over 2, 2 over 2, x over 2. And then this negative. And then I need to have a positive 1 here, so I'll divide everything by negative 1. So negative 2, 1, and negative 2x. And this becomes 3 over 2, 1, and then a double negative to make this a negative sign here. So it matches that form. Negative, negative x over 2. So there's my r and there's my a. And then over here wasn't too bad. Actually, we can just say a negative times a negative is positive, so we can not have to worry about that negative sign in the a, and there we go. And here my r will be 2x. So when we put this in our series form, a times r to the n, and this will be plus, and then this is my a times r to the n. We can take care of the negative sign, say negative 1 to the n, 3 halves, and this would be x to the n over 2 to the n. And this could be 2, and then we could say this 2 to the n, x to the n. So these are just ways of simplifying it. Then again, we could factor out the x to the n, like we did in number 13. And then we would have 3 times negative 1 to the n all over 2. And then we have 2 to the first and 2 to the n, so we could write this as 2 to the n plus 1. And then over here we could do the same thing, 2 to the n plus 1, which was just left after we factored out the x to the n. And my intervals of convergence, for this one, it was x over 2 between negative 1 and 1, which yields negative 2 to 2. And this is 2x between negative 1 and 1, which yields x between negative 1/2 and 1/2. And this is the smaller of the two intervals, so my intersection would be negative 1/2 to 1/2. Okay? Those are all the points that are in common. So when we take the intersection, it's always the smallest. It's the inside set of the smaller set. And there's your solution with the interval convergence. So it's a little, even more challenging problem, so I hope that makes sense. There's a lot going on there, so kind of really try to get as much out of it and thoroughly understand what's going on. And if you do have any questions, please ask me in class.